Hi, I'm Colin Wald, and we are the Ultra Pure Water Reuse Team, and we are working with Ultra Pure Water Reclamation for a semiconductor fabrication plant. This is being done to help out Broadcom. Broadcom is a semiconductor manufacturer, and their process uses approximately 1 million gallons of water per day where this ultra pure water must meet strict standards. The Ultra Pure Water Reuse Team is designing a process that will allow Broadcom to reuse the ultra pure water in their semiconductor fabrication plant. Semiconductor fabrication involves multiple steps, each of which use different machines, which are collectively referred to as tools by Broadcom. Ultra-pure water must be used in most of these tools due to the high specification requirements of the semiconductor wafers, but it quickly becomes wastewater due to the presence of various contaminants either from the wafers themselves or other chemicals used in the process. The end goal for our team is to use the waste streams from the fabrication plant to reclaim 10% of the water in the process to reduce overall water consumption and costs.
Hello everyone, my name is Karina Zita. I'll be discussing the market and competitive analysis for our project. Ultra-pure water is one of the many main components utilized in the semiconductor fabrication process for the purpose of rinsing off any remaining residuals left behind on the wafer. Due to the semiconductor market growing over the past 2 years, the demand for ultra-pure water is also rising with the prediction to double by 2035. The cost of production for ultra-pure water can be very expensive, as well as energy intensive. To mitigate these challenges, a wastewater reclamation system design will be implemented into Broadcom's ultra-pure water process. By increasing our water reuse, we are striving to stay competitive with top semiconductor industries, such as Intel and Texas Instruments, as well as reduce environmental impact.
Hello, my name is Caitlin Brennan, and I'll be walking through the team's schedule and budget for the past year. After initially convening and meeting with all of our advisors, the project scope and timeline were defined in September of 2025. Soon after, we moved into completing a market and competitive analysis where we looked into the semiconductor and ultra-pure water industries to determine that the project would provide a competitive advantage to Broadcom. In November and December, the process was synthesized and described, which meant determining first which streams were viable options for reclamation, and second, how best to repurify them. Right after winter break, we jumped right into optimization and sustainability analysis in February and March, followed by a safety analysis, and following those results, controls design. Our presentation at E-Days and the subsequent submission of our final report will wrap up the project nicely. We were initially provided with a $500 budget from CSU to help us achieve our goals, and Broadcom graciously offered to supplement where necessary. We didn't end up tapping into the resources CSU provided since the project is largely theoretical and design-based, but Broadcom did purchase and attempt to install a flow meter to assist in gathering flow rate data for our models. Unfortunately, with inconsistent flow through the pipes, an accurate reading was not able to be obtained from the meter. In conclusion, the budget provided by CSU remains untouched.
Hi, I'm Adam Davis, and I'm going to talk to you about how we came up with our process for Broadcom. Initially, we were given a list of a bunch of waste streams to choose from to see which ones had the highest flow rate and which ones could be realistically treatable. From that, we chose 3 different streams, one that's an acid waste, one that's a copper waste, and one that is isopropyl alcohol. For the acid waste stream, we decided that we would use a neutralization reaction with calcium hydroxide, where we send the acid water to a CSTR, neutralize it in there, and then send it to a clarifier to where the waste will get settled to the bottom, and the UPW will go back to the Broadcom facility for further polishing. For the copper stream, it was simple, just a simple ultrafiltration membrane to remove the colloids from the copper, and so the ions will then get removed in the polishing step at Broadcom's facility. For the isopropyl alcohol, unfortunately, we kind of had to give up on this idea because it became a very complicated process and there wasn't a lot of research done on how to separate the isopropyl alcohol from water in ways that we could feasibly do. So this is the actual design for our process from the 2 waste streams that we decided to move forward with, which is both the copper-rich stream and the acid-rich stream. For both streams, they are going to initially enter a holding tank before they get pumped through to their treatment operation. For the copper, it goes into the storage tank, gets pumped to the UF, and then the retentate goes to the waste treatments, which would be like the sludge, and the permeate will then go to Broadcom's polishing step. Same for the acid waste stream. It goes into the storage tank, then gets pumped on through to the CSTR, where the neutralizer will then be added in to have the reaction happen, goes sent to the clarifier or settler tank, which will be cleaned out of the gunk, and the water will be sent to the Broadcom polishing steps.
My name is Peyton Musselman, and I will be going over optimization. Our main goals for optimization for the UPW reuse system were to increase efficiency and decrease cost. One of the first changes that were made was combining the two CSTRs into one larger tank to decrease cost, decrease the space requirements, and overall increase system efficiency. The biggest change that was made was making the system continuous instead of batch. In the image shown, the first of each system is batch, and the second is the continuous operation. Continuous overall used less energy and thus lowered cost as a result. For sustainability, we looked at the American Institute of Chemical Engineers' 7 sustainability indices, labeled on the radar graph below. They're the metrics that help break down the various areas of sustainability. A score of 1 is very unsustainable, while a score of 7 is the most sustainable a system can be with the current technology. The inner blue and outer orange lines show the UPW reclamation system before and after improvements to the process were made. The main area of note is strategic commitment, as Broadcom currently has many policies in place that our system would hold to and thus would have a very high score for strategic commitment.
Hi, I'm Jake Footit. The 3 pillars of sustainability give a more in-depth look into the core pillars of sustainability, which are economic, environmental, and social. This project shows little negative environmental impact, with the only carbon emissions coming from the power provided by the pumps and agitation, with no extra land being used to install the project. This reclamation project does not negatively impact the communities surrounding Broadcom and will hopefully lead to jobs in the future. While further economic analysis is required, the financial upside of this project is near limitless, as there are many other streams that can be studied and recycled in the future.
Once again, my name is Caitlin Brennan, and I'm back to discuss the control system that was designed for the reclamation process. First, the 2 main storage tanks, as well as the reactor, were equipped with level control to prevent against overfilling and, in the case of the storage tanks, from running dry. Drains were also included on each major piece of equipment to allow for easy cleaning. A nitrogen blanketing system was also added to most of the unit operations to ensure that bacteria and other contaminants do not enter the reclaimed water from poorly filtered air in the headspace of the equipment. pH control was added to the reactor to ensure that the right amount of the neutralizing agent is being added at all times, and also to determine whether the product is in the correct pH range to continue downstream. Pressure control was added to the ultrafiltration module, and turbidity control was added to the clarifier. All of these controls together ensure the safety, efficacy, and efficiency of the reclamation system.
This reclamation project shows it has economic viability. The sales being calculated is a mixture of the cost of water being saved by Broadcom through recycling, as well as the amount of water being saved by bypassing the beginning of Broadcom's current purification system. As seen from the graphs, which use NPV, or the net present value, instead of just the cash flow, as the NPV shows a better estimate for money made over time, as it includes the interest rate, which is, as you can see, 15%. 3 lifespans of equipment were tested, each showing the total cash flow over a range of 15 to 25 years, with the 20-year being in the middle. And to get these estimates for how much money the reclamation system would make if proper maintenance was done, or that 25-year metric, and if little maintenance was being done on the equipment, that 15 or minimum year metric, these graphs show that after the initial building, a payback period of about 5 years can be found, with the longer lasting equipment showing a higher net profit over time.
Hi, my name is Marion Katzerbauer, and I will be wrapping up our presentation today. While only around 6% of the target water was saved, the system has been proven to be cost-effective and feasible to be implemented into Broadcom's facility. While the original target was not met, further research into IPA recovery would end up over-exceeding the 10% recovery that was originally targeted. Overall, the system has been proven to be effective sustainability-wise, and operation controls would guarantee specifications would be met. Thank you for your time and attention. Here are our sponsors from Broadcom and CSU. And here are our references for all of our data and information.